So I guess we should start the list.
Sounds good.
Are you recording?
I'm recording.
Okay. Well, this week I've been working on a bunch of different little projects and some schoolwork. Um, I did set up uh, a Kiwi SDR. I had borrowed Dave's for a while and enjoyed using it, but that was about a year ago. And so I set one up for myself. And I've been collecting some other little. Dave has got me interested in compute modules for Pi. So I'm looking at those a little bit. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things are going fine here. I've been very busy with schoolwork, writing reports and the like. I think things are going just fine. W2NF, back to net.
Very good. Next on the list, I have Bill, AB4EJ. Go ahead, Bill.
Com check. Hear me okay?
Yes, just fine.
Yeah. Thanks, Dave. Good evening to you. Good evening to the net. I've been pretty busy here. I've been going through my web front end and applying some additional error proofing. So on all my screens, I'm trying to make sure that I check as many user inputs as possible and try and avoid that people can put invalid data into anything in the configuration. Doing some final conversions of everything over to Python to get everything running in Flask, and right now working on the uploader, and also working with Case Western Reserve. I'm going to start doing some regular recordings that are comparable with what they're doing, except I'm getting the full spectrum using FFT to extract the results rather than using a statistical approach. And we're going to see if, how our data compares between those two approaches. And finally, did some work today on getting together the stuff we need for the National Science Foundation annual report, which we got notification is due now in big capital letters. Well, I'm thinking the end of the year is probably when it's really due, but I'm happy to put it together now so that, I have a lot of graphics, and, I've got, all kind of screen designs and comparisons of sample data and all this. But so far, it looks like the fast lane thing. What you got is you got 8,000 characters of text to put in. So I don't know if they're going to be. Travis is looking into whether there's a possibility of submitting figures and images to go along with that. But anyway, whatever. They're not looking for anything as complete as the final report. So we'll just basically tell them in words what we've accomplished so far and go from there. Back to Ned.
Fine business. Next on the list, we have Dan, N4XWE. Go ahead, Dan.
Good evening, Dave, and hello, everyone. Not much going on here. I did a little bit of work on the scripts last week, kind of cleaned a few up. One of the source code modules had a change, and I had to do a little bit of jumping around to make that work. I'm also interested in the Turing Pi and the compute modules, Dave, so that could be interesting. I did place an order for the latest version of the Turing Pi, although I'm really waiting for the one that accommodates the CM4
Yes.
to come out. Anyway, back to you.
I do see it's back ordered right now.
Yes.
So anyway, I have an interest. So next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Hello all. Yeah, I've been expecting a CM4, but I hadn't actually seen one or seen anything about it. But I played with those CM modules quite a lot in the past. Or well, I have a bunch of them. I got very frustrated. The documentation was the most inscrutable stuff I ever saw. And it's still like, it sounds like problematic, but I figured it all out finally. And I did not have the medical stuff I expected last week. Got delayed and through a series of misadventures, no fault of my own. And so that'll happen next week. But I've been busily going through the same process over again to get ready for that. And I guess I've been working to build myself. I went to the hardware store and bought even more PVC pipe fittings, and may well get a magnetometer buried in the ground here soon. We did get some additional information, I think from Hillman. I think it came through this afternoon, indicating that his comparisons between his kind of standard magnetometer and the prototypes seem to be just fine or good. Exactly how good I have some, I don't know, but he seemed to be enthusiastic about it. I think that went either the list or almost everybody individually who's on the list, as far as I know. Anyway, that's it from me. Back to you, Dave.
Fine business. And next on the list is another Dave, David McGaw, N1HAC. Go ahead.
Okay. Well, a couple of things to report. Well, Dave had sent me a couple of magnetometer boards, presumably to debug, one of which seems to work. The other one, I haven't found its hidden trace yet, solder bridge or whatever. The other thing is that some may have noticed that there used to be a magnetometer in Grafton, New Hampshire. I have now retrieved that. The last reported data, I think, was 2002. And Mike Trimpey, whose house it was at, is moving out of that house. And so everything's being liquidated. Anyone, well, actually, it's probably gone by now, but he had a large Stanford VLF installation there, quite old. But also had this magnetometer, and we were able to find it, dig it up. I've retrieved the magnetometer itself and the computer it was connected to. God only knows if it still works, but I'm going to give it a try and see if we can have a scientific magnetometer here in the Dartmouth area. So back to Nat.
Well, fine business. And let's see. Next on the list, we have Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just thought I'd check in, and I thought I heard last Thursday that some of the magnetometer boards, the new ones, were populated, and just curious to hear if those got powered up, if they might be running. Back to Nat.
Okay, well, we'll get to that in a little bit. Next on the list is James, KG4DSG. Go ahead, James.
You got me here?
Yep.
Yeah, I'm just lurking again. Just say hello to everybody. Interesting and educational listening to all of these topics. So I'll just back out and say back to the net.
Fine business. Next on the list, we have Jay, WB8SBI. Go ahead, Jay.
Aha, the webcam actually works tonight.
Yes, it did.
Oh, well, good to see you all. Nothing spectacularly new up here in Detroit. So the only thing that's of any general interest really is, did you hear that the FCC took away our allocation at 3 gigs? We lost that today. It's it's going over to the 5G network. So, not exactly happy news, but we fought the good fight. Otherwise, not really much new. Here, just sitting back, learning what I can. 73 to all, back to net control.
Okay, fine business. And next on the list is Jonathan Rizzo, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have much to report, nothing particularly exciting, just lots of work and schoolwork. But I was made aware of someone in the AM stereo community. His name is Chris Cuff. I don't know if any of you know him or have an interest in AM stereo as a broadcast format. But I was always interested in the technical aspect of it. And his health is failing, and he designed a lot of AM stereo circuits and receivers, and he also had this AM stereo, this CQUAM Part 15 transmitter that was available for sale or as a kit. And since he can't build them anymore and can't support them anymore, he released the Gerber files for a circuit board and a schematic, and he has some videos on his YouTube channel about how to build it. So I ordered some boards. I'm gonna build them up because I never got a chance to actually buy one. So I'm kind of excited to get that working and running and play around with AM stereo, because there's not any local broadcast stations in my area that broadcast in AM stereo anymore. But other than that, just lots of schoolwork, some documentation I've been working on for the VLF audio module, and that's about it. Back to the net.
Well, fine business. And next on the list, we have Mike, AA8K. Go ahead, Mike.
Well, thank you, Dave. Greetings to everyone on the conference. And I had trouble with the Tapper board election. I finally abstained because I wanted to vote for all 4 of them. Back to you, Dave.
Well,
they were all good.
That's a good choice, isn't it? To have
everybody good.
So, next on the list, let's see, Scotty, WA2DFI. Go ahead, Scotty.
Okay, you can see me. I got rid of my background, so
yes,
I can show you this.
Oh, there you go.
It's kind of fuzzy. I'll post a picture here in a minute, but that's the first production magnetometer, and here's a Raspberry Pi just to give you an idea of the relative size.
Wow.
And actually, if this is an Odroid M2, and it fits great on an Odroid because the Odroid is what I looked at for doing the fitting.
Mm-hmm.
So you can see how the RJ45 comes off here and comes out right over the top of the HDMI port.
Yeah.
So it actually, however, if you plug it on a Pi 3, and I believe a Pi 4 has the same problem, you have a little bit of a problem because the RJ45 interferes with the dual stack of USB.
Oh no.
So this is why we do prototypes, right?
Yes.
Anyway, so the idea is if you just fudge it a little and just angle it like that, it'll work just fine. And I think what we'll do in the next revision before we build a lot of them, we'll take this connector, we'll turn it 90 degrees, and it'll come off this way off the bottom.
Oh yeah.
And we'll also turn the jack around so that the prong is on the top, because
Yes.
the prong's on the bottom. So even if it was to clear the connectors, it'd be a real pain in the neck. You'd have to use a pen cap or a screwdriver or something to take the connector out, which is a nuisance. So, and they make high side latches, so that's no problem. It's just one of those things that you're not really going to be able to tell unless you try it on every board. And I'm curious as to what other boards might have something down here.
Scotty?
Yeah.
The Pi 4 has the Ethernet jack on the opposite side, but you're still going to run into the USB in the middle.
Right, because they're the same double stack, right?
Right, but they moved the Ethernet to the other side.
Yeah, I did see that. So that's okay, but because if you can see, we hit pretty much exactly hit the double stack of ports. So if they interchange this one and these two, we'll still have the problem right here.
You might be able to use a higher rise 40-pin connector.
Yes, and that is actually an easy option because you can take the 40 pin and you could just take another one of them and plug it in here, and you plug the bottom into here. So that would be a possibility too. And those aren't very expensive. So that for this version, that's what I think we'll do. Oh, so that's a Pi 40.
Yes.
Yeah. So, but anyway, I think ultimately, turn it so I can see the front, Dan. So the cable will be able to come off the bottom without any trouble. So I think in the end, that will be the solution that we'll pick. But for right now, Dave's suggestion of just using a longer cable. I looked for a higher rise connector that we could just substitute in the build, and I could not find anything that was taller than the standard 8.3 millimeters. So you could double them up. That's about the only way I see you can get them. And actually, go ahead, Dave.
Well, you can buy them from Adafruit and not from your major suppliers. They're hard to find, but DigiKey may have them, but only in little quantities reselling Adafruit or Spark Funds.
Okay,
ones.
do they are they tall in this fixed plastic part, or are they just longer pins?
No, they're tall. There are both kinds. There are taller, higher rise in the whatever it is, epoxy or whatever they make that stuff out of. The lower part. You can buy them, but finding where to get them in quantity may be more problematic.
We'll just have to sleuth that, because if Adafruit sells them, they don't make them, so they get them from somewhere. So we have to find them, because like the guy in the UK that we bought these connectors from, these black ones, they're made by Samtec. But if I go to Samtec in the USA to buy them, they're $2.50 a piece. If I go to the UK, they're 80 cents. So what it is he's just buying boatloads of them and reselling them at less of a markup. So that's how we built these.
Yeah.
Anyway, I haven't had a chance to do any testing yet. I had this emergency FPGA job that's winding down now, but it's still consuming my time. So as soon as that gets done, this is next on the agenda for getting things going.
Very good.
Back to you, Dave.
Okay, and next on the list is, I missed somebody. Oh, Tom. Tom, you always end at the bottom of the list. Sorry.
Yeah, I need to change my name and then I can move up the list.
You don't have a middle name that's got an A in it or something, do you?
Yeah. Okay, let's see. I loaded Cordis 2 Lite and the Max 10 device family. Scotty, is that the right device family?
Yes, that's the right one, the Max 10.
Okay, so I put that up on Linux. I just got it installed and up and running today. So I'm ready, but nothing to put on it yet. So be there when we get there. That's about it. Back to the group.
Well, fine business. And I think we've gone through everybody in the list, and we're open for general discussion.
So Nathaniel Do I need to get you anything for other than a picture of the board here? Anything for the report?
I think I'm good. I think I wrote up everything I need for this report, and I'm gonna make a couple small tweaks to it and turn it in tomorrow.
Oh, is this I'm talking about the NSF that's not due till the end of the year, but Bill says
Oh.
they want it now.
Well, yeah, so they start sending us these emails 3 months before the report's actually due. Yeah.
Yeah.
I know. So, and actually, and what Bill said is something to consider too. We may actually not be able to put any photos in it. So we may just, I may just have to write everything up into 8,000 words. So I think I get 8,000 words. Bill gets 8,000 words because, in Case Western gets 8,000 words. Because
And that's what, about 4 pages, something?
I don't know. Yeah, I guess so.
Used to be.
4,000.
You know, most scientists are procrastinators.
Yeah.
No.
Well, I'm not like, I think a lot of that procrastination is by necessity and not by.
No, well, hard work pays off tomorrow, but procrastination pays off right now.
That's right. But I like my schedule right now. Like I'm just constantly. I like deadline. There's just you can't do anything to the last minute because there's always something that has to be done before you do the other thing.
They're already all at the last minute, right?
Yeah, everything. Yeah, so it's just like I've been. Yeah.
And there's been less forgiving during the COVID period. It's like, well, you're not doing anything, so you can do it for me now.
That's right.
That's right.
Well, I know when we at our my business, when we on the few products that we had to sell, the Amazon mentality has ruined everything, because now when somebody places an order, they expect like ship today, because they want it like tomorrow. So they don't want to wait around, and so you better have it on. If it's in stock, then you better stop what you're doing, and you better go put it in a box and mail it out. Otherwise, you get a lot of trouble.
Yeah, it's crazy. But anyway, so I think.
So I'll send you a picture of this then. And
yeah, I think that the best thing I can put in my 8,000 words is that we have working hardware and we are testing it and it's looking good. I think if I can write that truthfully in words, then I think we're onto something.
Well, so I mean, if you want to say we have working hardware, all we have is one board, but that's working hardware, right? So
yeah, it sounds good. And I think it's not my particular part of the. I think my report will be able to incorporate things that all the other groups are doing too, because I kind of have like the top overlevel one. But one of the things I did do, I have to, as an untenured professor, I have to submit a self-report to the university every year while I'm untenured, and I have to write like everything I have done in the past year. And so
hopefully you maintain a document so you don't have to sit down and write it all at once.
Yeah, well, I do maintain running things, but there's always stuff to change. So it's almost all written. I have like a couple things. It's due tomorrow, and there's like two things I need to add in or something like that. But the document's currently like 155 pages.
Yeah.
And
jeez.
So Dave, is that the right length, would you say?
Well, they may ask you to condense that, but it's good to have the whole document so that you have all the information there.
Yeah, I mean, what I did was I took like all of my course syllabi, all of my course evaluations, the grant proposals I wrote, the ones that I got funded on this year, they all went into appendices.
Yes.
So yeah, so it's all like, and then I have like 20 pages of writing at the beginning that says, and in this section you can see blah blah blah, and I did this. Yep. But one of the things I did do is I have a reference section where I actually cited every single personal space weather station talk that was given at HAMSci or at the Digital Communications Conference. And I said, this is evidence that we are making progress on this. And I provided web links to all of it. So
it's all steady progress. That's what they want to see. Steady progress.
I have lots of steady progress in there. Lots.
I'm sure you do.
What
But
do
I'm
other
enjoying
colleagues
not.
say about how to do these kind of reports? Do they say, oh, well, yeah, you wrote this much, but you really should have written this much? Or what's the word for
my
other
goal
colleagues?
is to hand it into the tenured faculty members and the administrators, and for them to pick up and go like this and be like, looks good, done.
Yeah.
That's my goal. I don't want any discussion. I think it'll be okay.
Yeah, and then there's always something about if someone asks a question, you can say, oh, yeah, I covered that. See page 32.
Yes, exactly. Like, it's in the report.
Didn't you read?
Yeah, really. You really want to say that, don't you, Dave? It's like, hey, read.
I mean, the one I turned in last year was very similar, and it was 140 pages, and I had only been working there for 3 months. And and they didn't tell me it was too short, and they didn't tell me it was too long either. So they said thank you very much. It looks good. So I'm like, okay.
But how do you know if it's been accepted or graded or scored, or do they tell you that, or they just file it?
No, they tell you that. There's actually a formal process. So the first thing I have to do is I have to send it to all of the tenured faculty members in my department, and then they have to have a closed meeting expressly for the purpose of voting on this. And they all vote on whether or not, they approve of me for another year. And then they write a letter in support of me to the dean and the provost, and then it goes through administrative review there. And then I ultimately get a rather lengthy reappointment letter.
Okay.
What happens if they don't approve you? Do you get fired?
Yep.
Really?
Yeah.
I was just kind of joking.
No, it's true.
Pre-tenure, that's pretty standard.
Ooh. So do they judge you by how many contracts you bring in?
Yes.
Art
and papers you write.
Yeah.
That's an important factor.
Wow.
So how much longer do you have to do this?
It's a 6-year process, so I'm on year 2.
Oh boy.
Now,
Well,
if you do it right, it goes through pretty smooth. But if you do it wrong, it can be extremely painful.
That's why my report is 155 pages long.
When you get the next NSF grant follow on for 3 more years, that's your 6 years right there.
Hopefully. I actually, I'm a co-I on a NASA grant that was funded this year. So that's another.
Oh, those are good feathers.
Yeah, so I got that, and that's a 4-year grant, and it brings in. It's not as big as a DAISY grant, but Scranton doesn't have any NASA grants, and now they do. So that's a nice thing. Yes. And so I have both NSF and I have NASA, and I was also selected to be on an international Space Science Institute team that meets in Bern, Switzerland, and so that's another one that was put in. And then and the grant also. The grants I have, they also include, one includes some funding for a graduate student. So I'm actually like paying student salaries. So
how many grants does Scranton get? Just as a measure of, I mean, you're like 3 or 4 grants. Is that out of 10, out of 50, out of 100, out of 2?
Scranton's, more of a smaller liberal arts teaching sort of institution that, I mean, Scranton is not a Research One institution. It's not one of these places where you have to, bring in lots of grants and you have to write lots of papers. You need to do a little bit, and you need to be good at teaching. That's kind of like the winning combination there. But I think so. I think I'm well on target. The
3 or 4 grants that you brought in is probably a good percentage then.
It's significant, yeah. Yeah, it's significant.
So can we get a discussion going on this board we're looking at?
Yes.
So there it is.
So,
And it looks like the solder mask is red, but it's really kind of a faded orange. I wanted day glow, like safety orange,
Yeah.
but and it really is not red. Okay, that's just because of the lighting in my room here.
okay, so you got burnt orange instead.
I got what?
Burnt orange.
Burnt orange. Yeah, that's it.
So I noticed C7 is missing.
C7, yes, C7. There's several. There are 23 parts on this board that are do not installs.
Oh, okay.
Huh.
And they're mainly because of here are the two quick connectors. You can see my cursor, right?
Yes.
Yes.
So here's the two quick connectors. So you could connect it to a SparkFun adapter board with their connector system. This is a 5-volt power in if you want to power it with a flying 5-volt power lead. This is a Grove connector if you want to plug it onto a Grove system with a double-ended cable. If you want to populate this connector here, this is a PMOD connector, so you can run it as a PMOD board if you want to install that connector. And then all these parts underneath here, this is a duplicate of the parts that are on the header that plugs on these two connectors. So if at some point we find out that we can't get those development boards anymore from P&I, we could just buy the raw IC and the 3 inductors and a handful of other, non-essential like resistors and caps, and we could place them on here, and then we would just depopulate these 2 connectors, and we'd have our own board with no magnetometer module required. Of course, if we did that, then we'd have to have a remote version and a local version, because there's not really any way to disable this. I didn't put that on the board, so figuring that this is just a belt and suspenders thing that I don't really think we're ever going to use. But since this whole area underneath the P&I module is kind of empty, this is actually an exact copy of the layout of the P&I board. We stole it right off the board and put it right on our board. So it should function identically to the P&I board if we wanted to solder the parts down, just for laughs.
Okay. Can you see the red line I put on the picture?
Yeah, right.
Okay.
C7 is additional bypass capacitance on the 5-volt line that goes out to the connector. And you can see the C13 right below it.
Yeah.
Was increased from, I forget what the value is. I think it's 220 microfarad right now, that capacitor is. The problem is that capacitor costs about $2. So this C7 is here just in case we need to add another capacitor, but it increases the bill of material cost by 25% by adding 1 part. So I opted to make it optional. We originally started out with 22 microfarad, and then I know Jules had said he would favor more, and I think Dave, you said also that it's trying to keep the smooth out the peak current on the remote end is what it's mainly for.
Okay.
Yeah, I never have worked with that much more anything. And in fact, I thought when he had 220 or 260 or something in his notes, I thought that was a typo, but I really did. Maybe I didn't understand properly.
Yeah.
But it's been working without that.
And so I believe this capacitor over here, no, that's the ferrite B. There's another capacitor in here that is a 22. It's probably, I don't know if it's an 0402, but at any rate, it is in parallel with this one also, and it is hooked up to the transceiver that drives the cable. And it's probably one of these 2. Oh yeah, you're right. There you go, Tom.
It's C18.
And this is the driver right here, so it's right next to the driver. This is not a huge one like this, although it looks like it's the same size, but I believe it's smaller in capacitance and therefore much cheaper. So, and then this jumper here is normally, if you plug the thing on the Raspberry Pi, it shorts this jumper. And if you don't plug it on the Raspberry Pi, it leaves it open and there's a pull-up on it. So normally in normal use, you would not need this unless you were going to run this standalone on flying leads and not plug a Pi into this 40-pin connector. Then you'd have to have a way to shift addresses by pulling that thing down. But normally you don't need that, so we left it depopulated. And then this is a local remote jumper, and mainly it connects up the interrupt line, the ready line coming, the D-ready coming back from the chip. And if you see also, I believe this is a 0 ohm resistor right here, right below the fuse. And if you strap this to local, I believe, and you put that 0 ohm resistor on there, then you disconnect the D-ready line and you add a second line in the cable for power. So if we get to the point where you want to have more length in the cable and you got too much voltage drop and you don't really care about D-ready anyway, you can add a resistor and jumper this, and then you can have get 25% less resistance in the cable going out to the remote.
Is that
That might be good for me if I have like a 150-foot, 200-foot cable run.
According to my calculations, it will run up to 350 feet without the jumper. And
Okay.
if you need more than that, then you may have to put the jumper on there to get it to work. And have the resistor in here too. That's important.
And Jules has been running the stuff pretty consistently over things in excess of 300.
But he's using 2 wires for power, right?
I believe so.
Yeah. So like I said, the calculation says 350 before you start hitting the dropout threshold, because the regulator that we use, and I think it's this guy here, it is the 5-volt, the 3-volt regulator at the current that we're drawing, which is under 10 milliamps. In fact, it's significantly under 10 milliamps. I hardly believe this myself, but the dropout voltage is like 5 millivolts. So, I mean, now when you go up to 300 milliamps, now the dropout voltage is a few hundred millivolts. But at the low currents, it's very, very, very low dropout. So should theoretically be able to run this out to 350 feet. And that was with 28 gauge wire. I don't know if that was Cat 5 was 28 was what I was told. So I did the calculation on 28. If it actually is 26, then you get even more length.
I think it might even be 24.
Yeah, normal Cat 5 is 24.
So with 24, I don't think you're going to have any problem unless you want to run it in the next county.
Yeah, there'll be time. Scotty, are those resistors 0402 sized?
Yes.
Okay.
All these parts, like all over here, these are 0402s. This is an 0603 here. And these are like 1210s.
Okay.
And this is even bigger. This is like a 3220 or something, this fuse.
Right. Yeah, that's the fuse. Well, the thermistor.
Yeah, the PTC. Yeah.
Yeah.
And so what we added, this right here, this diode. This was the reset circuitry that Dave put on his board that he called our attention to, that you can't just tie the enable high, that you have to have a reset pulse. Maybe you saw it, Tom, I don't remember.
I think Tom, yeah.
Yeah, anyway, so it's this resistor, or this diode, and I believe this capacitor. At any rate, I was going to put a BAT54 diode because, I have those. They're really common, but look at, this is a BAT54 size up here. And this is the diode we used. The CAD guy was screaming about this thing being way too big. There was no place, there's no way he could fit it in anywhere. And so we ended up, I think this is an 0603 size diode, this being an 0402. And so we switched to this diode instead because the microscopic SOT23 was too big. So.
Okay.
So let's see, is anything else that is optional? I don't think. I think pretty much everything else is on the board. And this jumper over here is the right enable for the PROM. I still haven't figured out what we're going to put in the PROM. So if anybody has any ideas, I need to go research what's normally in a Raspberry Pi hat ROM. I think we need a UUID or something unique for us, probably unique for every board. I'm not sure what we need to do.
I think they've just kind of fallen into disuse.
So we just bother programming.
Yeah, when you plug that into the PSWS, is it going to recognize this as a version 1 magnetometer board? As opposed to some later version, does the PROM hold that information?
It can if we program it in.
Yeah, because I think we need to revision control module so that when we take data, the metadata will say what version of the module was used for a particular measurement set.
Makes sense.
Is there anything on the back side of the board?
No, no components. Well, this connector up here, the 40 pinner, but that's mounted from the reverse side, but there are no components on the back. I have a back side too. And the other thing, I didn't get all the logos on the back side that I wanted to get on there because Dave was already getting so mad at me. Dave's our CAD guy, that if I asked him for another thing, I think he'd hang up the phone. So, but when we do the connector rotation, I'm going to get him to put the HAMSI and the other logos on there. And I'll send you a picture of the back side. I took it, but I just didn't send it because I figured you're probably way more interested in the front side anyway.
Yeah. So all you have to add, what do you have to add to make this thing work now? You have to add the magnetometer module?
The magnetometer module on the remote end, and on the local end, nothing.
Okay.
And if you want to just run it locally, which is not recommended, you can plug the magnetometer on and just plug it on locally and not even use the RJ45 connector. I mean, that'll be enough to read the magnetometer and see that it's there and all that, and test it. Because the manufacturing test is actually going to have to be 2 tests, because we have to verify that we can read the magnetometer locally, then we have to verify that we can read it on the far end of the cable also. So we have to test it in both configurations. And so that's part of one of the things I got to come up with, because when we go to manufacturing, which once this tests out is going to be pretty fast, we're just going to have the CM test it. And what that does for us is that means I don't ever get any bad boards. Because the first time we did this with us doing the testing, the CM just built 500 and sent them to us, and then when 50 of them fall out, now I either get to eat 50 boards, or I have to send them back and get them tested, and yada yada. It goes back and forth, and then you go, no, we're not going to do that. We're going to send a Raspberry Pi to the CM with the software in it to test. And a written procedure that says you follow this, everyone passes this test, or you don't send it to us. And then I can say, give me 500, and they build however many it takes for them to get 500 that work. And typically they'll build 550 or something. And in fact, most of the places, it hasn't been true with our Hungarian counterpart, but most of the manufacturing places, you agree to take up to 10% more boards than what you ordered, because they have to build enough to guarantee your minimum, but they don't want to be stuck with a bunch of extra boards. So typically you order 500, you might get 510 or 520 because they're going to build 550, and then 30 of them are not going to work. And I'm thinking in this particular case, they better not have 30 that don't work, or they got some problem, because it's so simple, you know. It's not,
and then you pay for those extra ones that do work.
You pay for the ones that do work, but you do not pay for the ones that fall out that did not work.
Okay.
But of course they build it into their price, so it's you're still paying for them anyway. But it just removes the necessity to fight over, this board didn't work, I want a new one, you know. Or when I order 500 for my customer, and my customer wants 500, and they ship me 480, then you know, somebody's upset because they didn't get the number of boards they wanted. So let's see if this, I can send you the back side.
Scotty, if you were to populate the components for the magnetometer on this board itself, would there be interference with those with the inductors, like the shield of the RJ45 or any of the other metal?
Well, we think not, because basically the only difference is about a ½ inch higher, but it could be because now you're down behind the shield. So I just don't know.
Okay.
And one of the reasons is that that's why we preserve the layout exactly of the parts, because I didn't want to in case we did build this and it had trouble working, I didn't want it to be because, oh, well, you didn't lay the board out the same. So these traces don't you know, they have a problem. You didn't route the inductors properly or something. We copy the exact trace layout of their board. So if it doesn't work, then we at least know it's something external, like the RJ45. And
I don't.
I suppose we could use a non-shielded version, but then we don't get the shielding.
Did we find a non-magnetic Ethernet connector?
I did not. That's a steel one.
Yeah.
I found lots of them, but
are they shielded?
I'm not sure. Yeah, but
so they're not shielding then instead of
brass, whatever.
Brass?
Yeah, tin brass or something.
Is it?
But
brass, doesn't it have magnetic properties?
Not that I'm.
Because I know if you use brass in coils, it actually changes the inductance. Right? Reduces the inductance, actually.
It's probably the difference in conductivity.
That's because the permeability is different. Okay, never mind.
Yeah. But I don't think it's. I really don't think it's all that twitchy either. I have some Drotech versions of the magnetometer that were made for drones that from somewhere, and they're quite a bit smaller. They scrunch things together a lot and put them in a little box. They run them off SPI. Well, they have both I2C and SPI. But
so it would be worthwhile then to get a non-magnetic one when we rotate it.
Yeah, that might be smart, but
yeah,
I'm not convinced whether that was ever a big factor. But as far as being thorough, it certainly seems like a good idea.
Okay, where'd my picture go? I'm trying to get I mailed it to myself from my phone because it's much easier than trying to plug in the phone and download the picture. Okay, let me move this off of here.
That's your beach in Arizona?
That's my back door.
Oh, okay.
It's not bad, Scotty.
I wish. Okay, I got the other one.
Sure.
Too big. Okay, how's that? That's the back side.
It's awful nice to put a little square pad of white on somewhere.
Well, what's going to happen is
so
up
that
here,
you can write something on them.
right across here is going to be a serial number label right from there to there. We made sure to leave a long space for a quarter-inch label to go right across here. And then ideally, we'll put the ham side and SF logos and all that across here below it.
Mm-hmm.
Which I didn't. The trouble is I don't really have them in the format that the CAD guy can use, so he's going to have to trace around them, which is more work for him. So when we go back and have the connector rotated, I'm going to get some more money from Tapper to pay him something so he's not so mad at me because he bid this on a fixed price and he was a little bit over. So when I came back with the two changes, because you notice it's Rev C if you look at the front, he did two updates on it for nothing. So
yeah, I see the Rev C there. The right, upper right.
Where is it, Rev C on this side?
Just above Zephyr Engineering Incorporated, to the right of J9.
Over here? Oh
Yeah.
yeah, Rev C. Yeah. It's in the silk screen on the other side.
Okay.
So, it looks a little more orange here too, doesn't it?
It does.
Just to give you an idea, this paper back here is a yellow pad. So it tells you how good my colors are.
Yeah, you're a little weak.
They're not
on
quite
the yellows.
calibrated.
Yeah.
Well, it could be whatever light you
Yeah, and I've got
photograph.
6500K LED lights, so it's quite blue.
Oh, 60. Yeah, that's very big.
Yeah.
So it makes
Scotty,
it
that
fun.
notch on the right side there, that's for the to uh, uh, give enough room for the M2 socket.
That's to give enough room for the, I believe it's the camera. It's
Oh.
you can see here. You can't with my background, but there's a right underneath here. There is a flex connector cable that comes off of the Raspberry Pi that is for either the camera or the external video, a flat screen.
Oh, that's right.
And then over here by this our board's not deep enough to bother with this, but right below here, below the hole, is another flex connector. But we don't bother that one because our board isn't tall enough. So, but if I had to make the board any bigger, I would have had to notch that out for that connector, that flex cable.
Oh, okay.
So that's why I did not want to, didn't want to make the board any bigger. Just barely clears too. And actually, this has some depth to its contact surface. So if we put 1/2-inch spacers on these two holes and leave it up off the board a little bit, it still makes contact and it gives you enough clearance to plug in the RJ45 on the Raspberry Pi. Just barely enough. So you might try that. What's that part that was outlined? Who drew that on there? Is that you, Tom?
Which
Somebody drew this.
That's I think the part number of the board. It
Oh.
says TSDR dash.
Yeah.
Yeah, so I think that's the Tangerine part number.
Yeah, the 8000. That's the one we had talked about, Tom, and we made up the document list.
Right, so that should be the orderable part number.
A Mag 8000.
Yeah.
Sounds like a car. What was that car that was it Mad Max or was it Cherry 2000 that she had? It was anyway, some souped up Mustang, I think. So you can see there's nothing on the back. Dave tried to get me to let him put stuff on the back, and I wouldn't.
Scotty, you got too many Daves around.
I know. Dave Baldwin is our layout guy. So, and he doesn't have a ham ticket, so I can just call him Dave No License. So anyway, that's it. So I just got to get the Raspberry Pi fired up and get talking to the thing and make sure I can read everything. Then I can release the other 45 units to be built.
Looks good.
And that is
Yeah,
all.
looks great. Can't believe we're seeing actual hardware.
Real hardware. So first hardware.
I know.
Well, not really first.
Well, the very first one was, we saw it at Hamcation, right? It was Dave Whitten's very first.
Yeah, Dave had the first board, but we stole all of his good ideas and put it on this board. So
right,
it's still part his board. I think half of the things that mistakes we avoided, at least so far, were because he figured out things that he told us about, like that diode on the enable. Either Tom or Dave. I mean, we had a lot of eyes looking at this, which I think is good. I hope that means that it's going to just sail smoothly right through.
Scotty, there was something you were showing. When was it? On Thursday? You had. Did you have a prototype of the data engine? You had something with a light, a series of LEDs flashing back and forth across it.
Oh, yeah. That was another project I'm working on. That. Hold on a second. I will, let me stop sharing this if I can figure out how to do this. And
By the way, there is a riser connector on the Adafruit website that would allow you to lift the board up over the top of the Raspberry Pi by a significant amount.
Okay. What does it cost? A couple bucks?
It's $195.
$195. Well, I could just send another copy of this connector that's 80 cents with the board, and it'll get up an inch and a half.
Yeah.
8.5 millimeters of solid, and then 10 millimeters of tail. So about 3/4 of an inch, maybe. Well, this one here, this is the DK board that Dave and Dan, you guys have.
There. Yep.
And I've got my my LEDs. Yeah. So we all have these boards anyway. I just picked this board because it has the same FPGA on it that we're going to use, except it uses fewer pins. So it's not quite the same FPGA, but it has the same number. Internally, it's the same, just has fewer pins. And the one I was working on for the customer was remote configuration. Funny thing about that, right, Dave? It's like the first thing we're going to work on as soon as we get the FPGA going. But the kit is great for doing that because it has all the same stuff that we have on it.
Right.
So it has the same QSPI on it. It has the same DRAM. And, you might ask yourself the question, where did we get our QSPI and DRAM? Well, mercilessly stole it from these guys because that's what you do. I mean, that's what's recommended anyway, because you want to pick something that works.
Yep.
So we picked the same chip. Now any code that I get that works on this board, I can just import directly, and it works because it's the same memory. So yeah, Tom, you might want to buy one of these boards if you're interested, because it's really got some good. It's a good way to learn FPGAs if that's what you want to do. I presume that's what you want to do. So.
Yeah, I got the kit just in case during receiver checkout, we've got to make changes to the FPGA.
Okay.
Would you put that kit in the chat?
Sure. And I think DigiKey still has a whole bunch of them left, because I don't mean to say left. They stock a whole bunch of them. It's the Intel Max 10 DK board.
I need to get back up on the non-Xilinx.
And all the software for this is free. All of the Tom, did you load the Neos tools also?
Neos. Yeah, I got the 2.something gig light download.
Okay.
But not the all tools, just the download, and then you added whatever families. But I think it included the Neos stuff in it.
I think what you probably did not include the simulator, but it did include the Neos, and then all the free parts, which are the Max 2s and the lower side Cyclone 5s and all the Max 10s.
Okay, so is the simulator needed?
No, not really. Simulator is very, how shall we say, challenging to set up. So what is really more useful is to use something called SignalTap, which is a logic analyzer that loads into the FPGA that allows you to capture the signals in real time and read them back out, and it uses a JTAG interface. So, and while we will not have a byte blaster on our board, so in order to use SignalTap, you're going to have a byte blaster, so a hardware byte blaster. But
there's still to connect the byte blaster to the DE.
Yes, there's a header on it to connect that up. And because I figured we didn't need to everybody didn't need to pay for a byte blaster, because once we get released, nobody's going to need it anyway, because Dave and I are going to have this code that's going to be able to upgrade the software.
Dave, are you working on the code to download the FPGA PROM?
Not yet, but I did work on something like that on the Hermes. So I have an idea of how to do it.
Okay, so the update process will then involve running that kind of a tool.
Yes.
To download new PROM contents and then rebooting or re-whatevering.
Yes. Well, we'll be rewriting the flash. So there's
Okay.
a flash section, and I'll write some software that just puts the flash image in, or the image into the flash, and then you do a reboot on the board and it'll just pick up out of the flash.
Okay.
And the flash is a lot saner, hopefully, in this one than the other one. We had to build our flash petitions in the Hermes, and this one has two sections of flash, and they fall over. So we can have one that's kind of like the default if nothing's there, and or we can, I mean, there's several ways we could work that.
Okay. And for updating the proms on the modules, Scotty, are those going to be permanently written at manufacturer time with serial number and board type and revision, or will there be a tool to write that in there?
There will not be a tool to write that in there because it's intended for manufacturing only. So that's the way I'm thinking of it right now. Because if you let anybody write it, then you just removed the advantage of having something that's fixed that you can program once. The other thing is the FPGAs also have a unique serial number program or burnt into each one. So we can use that possibly. So instead of the because I wasn't planning to put a serial prom, and actually I take that back, I do have a serial prom on this board. So the one we have on the memory module, that serial prom, that ID prom, I have one on the data engine also, but I do not have one on this. So what I have is the prom that was called out for by the Raspberry Pi Foundation or whatever. If you want to have an official Raspberry Pi hat, you have to have the prom. So that's kind of why I'm looking at what to put in it, because I'd like this to be an official Pi hat that anybody could use on a Raspberry Pi anywhere, and it would be identified properly. But I'm not sure exactly how to do that just yet. So anyway, Dave, let's see, Dave, where did Dave McGaw, I think you were asking about the kit.
Yes, I got that. Thanks.
And here is the Intel part number, just in case that awful URL didn't come through.
Actually, it did. It worked fine.
Okay. There's the merciless Intel part number, merciful Intel part number.
Anyway,
The reason I like this one is it has two Ethernet ports on it. So, but not a bridge like we have, but it's got two separate ones. But to instantiate two Tri-Speed Macs and a Neos processor, you're not going to have a lot of room left to do, radio stuff, which is what we want to do. So, but it's a great board for testing and debugging. So I pretty much got the Dave KV0S. I got the alternate load images. I'm able to trigger one to go to the other, trigger the main one to go to the boot image, and then the boot image. Because I'm thinking we might want to do this the same way as my customer is working on it, who I'm working on it for, is one image is just the bootloader. So we get the whole FPGA to work with. We don't have to worry about having any operational code or anything in that. And then when we switch back over to the operational code, then the switch portion that detects a switch over is just the dual boot IP, which takes about 0.4% of the FPGA. It's very small. So it's like, I forget, it's like 79 LEs or something is all it takes, 72 LEs. So we don't have to put a Neos on it, although we'll probably have a Neos on it anyway. So I'm not sure it makes that much difference. But the other difference is we're going to be doing this over Ethernet, right? And I'm doing this over serial port. So to start with. But it's not trivial because they don't really tell you how to do all this stuff and how the images work and how to load them.
Right.
You gotta go figure it out. So I'm hoping that I'll remember enough of it to the exercise will be useful.
Well, a lot of the code outside the FPGA was written by John Melton. originally.
A lot of
The code that I was working with to make John Melton had written the first attempt at it.
Oh, the PC code, you mean?
Yeah.
Talks to the loader?
Yeah.
Oh, okay.
So he's still.
I thought you were the original author of
No,
all.
I just took his code and rewrote it because the problem was his code, the user interface, was very confusing to anybody who didn't know all the details of how the board was built. It made all the sense in the world if you understood it, but it took a while to get your head around what it was doing. And what he had done is taken what the Quartus was doing and figured out, well, we don't need all this other stuff, but we need this little bit. And so he made just the code that did that.
Okay. Well, I hope that this will be a little easier because we have this fall over in hardware inside the FPGA.
And the other thing is the first attempt was on the Atlas boards, and that had no error checking at all. So it either worked or it didn't. And if it worked, everything was great. And if it didn't, people were scared to death they'd ruined everything.
Well, the interesting thing is that the flash ROM interface is a 32-bit wide write.
Okay.
So it's different than, you can't send a whole sector to it unless you want to buffer it up yourself.
Right.
So I don't know if we want to send 4 bytes at a time across the Ethernet or whether we want to try and buffer at least more than that. Because a sector is 8K bytes. And I don't know if we have enough. Well, yeah, we do have enough RAM to do that because we're going to use external RAM. So,
yeah. But it's possible. There's several ways we can do that.
Because that's one of the things that the one I'm working on now is very restricted because the particular hardware has no external RAM and no external flash. So the bootloader has to operate totally inside the limitations of the FPGA. And it's got, I believe, 16K, 4K, 64K of flash. And it has about 1.5 megabits of RAM. And what it does is it copies the flash into RAM. So let's see, so that would still be, that'd be about half the RAM then, or a little bit less. So, but the point being is that I just tried to compile it before I got on here. If you use printf and scanf functions, it won't fit in the internal ROM.
Right.
Because the C functions are way too big. So they have an option to use the reduced size C functions, and it takes all those hairy complex ones and throws them away. And now you get like get char and put char. So you have to do it yourself.
Yeah. Well, that's not that different.
Yeah.
So, and actually, John's original code, it didn't use very big packets, so they were quite small.
Okay.
And he just sent a lot of them.
Well, we can. I mean, if we did 16 bytes, or 32 bytes, or 64 bytes, any of those, are as long as we can do multiple 32-bit reads off of them.
Right.
No problem.
Yep.
And you know what is a real riot too is that the code that generates the hex file or the RDN files.
Yeah.
It has the wrong Indianness.
Yes.
So the loader has to swap.
Yeah, you have to be very careful about what Indian you use. So.
That's right. So I'm just looking at the code and I'm going, what in the heck are they doing here? Swapping bytes around, and it's like, oh, I get it now. You have to do that.
Yeah. Yeah, that's the other thing that takes a while to make sure you get your head around is that they all aren't the same.
Yeah. So anyway, we're pretty much other than the finishing up the data engine schematic, which is still languishing because of this other work that came in. I got to do an FPGA load and start doing some testing to make sure the pinout's gonna fit.
Yeah.
So, and the good news is once you get the news on the pinout, you got the shell for the FPGA code right there to start
Right.
with.
Right.
So it will be fun.
Do you think that this dev board might be a good tool for me to use for the VLF module?
I
Like
would I would wait for a data engine,
okay,
and especially since you'll probably get a data engine for nothing, and you won't have to spend $200
right,
because being a developer, because it's this is great to learn how to do FPGAs, but if you want to try to port data engine code on it, okay, well, if we do the Ethernet stuff, that'll port directly over.
right.
Actually, I should take that back because we use a different PHY than they do. So maybe it
Okay.
doesn't port directly over. So I hate to see you spend $200 and then try to get any of our code working on it and you won't be able to.
Yeah, I was thinking that because I was thinking porting might be just as much of a nightmare as doing the Verilog. So yeah, maybe it's best if I just wait anyway. I don't know what your timeline is. I don't really have much of a timeline right now, so
I'm looking for the end of the year for prototypes.
okay.
And it seems like a long time, but that's not very long. It's only like 10 weeks.
It's already October. The end of the year is fast approaching.
Speaking of which, did you guys hear they canceled Hamcation in 2021?
Yeah, I saw that this morning.
Mm-hmm.
I thought of you, Scotty, when I heard that.
Yeah.
You're the one that usually goes to that.
You know what's ironic about it is I was on the Southwest Airlines flight to make my flight reservation last night. I said, no, I think I'm going to wait another day or two, and then they had canceled it this morning.
Yeah.
This was like, wow.
That was
lucked
smart.
out there.
It's going to be interesting to see what can and can't be done in 2021.
Yeah, yeah.
Mm-hmm.
So, and Nathaniel, Hamside is already going to be virtual, right?
Yeah, I think it just makes sense.
Yeah. It's too soon to tell.
Yeah, and it's so much work to put it together, as you well know. But it's like to put it together and then have to take it apart. It's like it's just too much.
So don't you think it's actually a little bit less work to put together the virtual one than the real one, in-person one?
Yeah, probably a little less.
But then you got to do both, right? You had it all put together in person, and then you had to switch in the last 2 weeks.
Right, and that's that's what I want to avoid. I really don't want to go put the whole thing together and then have to say no. I just want it to go smoothly.
Dave's getting ready to hit me with that pipe.
With what?
This is my underground enclosure.
Oh yeah.
Looks like a telescope.
He's using it to adjust his camera.
As long as the vaccine is out before Hamvention.
Well,
And
I'll
you have
be
to-
happy.
but you do have to take it before then.
Oh yeah. But I'm only 4 hours up Interstate 75 from there. So
okay.
You know, the one that doesn't work will be out before Hamvention. But if you want the one that works, it's going to take longer.
might get this.
Yeah, Dave, you need to put an auger bit on the end of your pipe there. So that you
Oh, he has an
a T handle, and you could just kind of screw it into the ground.
Well, I have some auger bits that go into my electric drill, which of course, that was a good excuse to go buy a new lithium-powered electric drill for use out in the yard, because I was sure that the ones I had weren't
Have
up
you
to
ever
the
used
job.
one of those gas-powered augers?
No, I've seen them, and I was like,
I used a two-man one to put a fence in at my old place 20 years ago. And my buddy and I got the thing out there, and we're in Arizona, right? And the caliche soil out here is about the same consistency as the low-grade concrete that you buy. The guy told me, the guy at the hardware store said the 2,000 PSI concrete you buy, the caliche is about 3,000 PSI as long as
okay.
it's dry. As long as it's dry, when it gets wet, it turns to this sludge that, you know. So
Okay.
me and my buddy are out there. We get this thing fired up, right? And there's handles, cross handles, right? So each guy gets 2 handles, and the auger's turning, and we set it on the ground, and it screwed itself into the ground, and we couldn't get it out.
Oh no.
And we're just going like, what do we do now? How do we? So I think we had to turn it off, and then we had to rotate it backwards by hand to unscrew it from the ground.
So there was no reverse or what?
No reverse.
Okay.
And so the trick is you have to hold. You're pulling up all the time. You never push down on the auger. You pull up against the screw so you are pulling the dirt out. It's screwing it up, but it's trying to screw itself in, and you're holding it so that it pushes the dirt out and it doesn't go down. But
So
You get to pull up the weight of the machine plus the weight of the dirt every time.
that's
yes.
right. And if you get a little excited and go in too far,
Scotty,
down.
you just need to hire some person with one of those on the back of a bobcat and then take care of it.
Yeah.
Oh, well, let's see, what year was that? Well, I hate to admit this, but I was way, way, way younger then. And,
Okay.
those kind of tasks were better done by yourself. You don't hire that stuff out, right?
Yeah, right.
Well, I do now because I can't do it. So,
anyway, we are past time.
Yeah.
I think I will say
I know Nathaniel's
That'd
been
be
yawning quite a bit.
yes, yes. But I've kept in good spirits and it's
Yes.
been a good evening.
It ought to be cold enough where you are.
It's getting there. I've got a little space heater.
yeah, I see
Here.
Bill has a jacket on too.
We're probably we're looking at changing our heat over from oil to propane, so we're going to take a look at that later this week. And
Yep.
get
Well,
more.
Here, just in leaving, I'll give you a screenshot of ours.
Wow.
Oh, 95.
That's what it is right now.
Yeah. We've
And
had really.
Tomorrow's high.
See
The
this
high
here?
of 102 this week. Wow.
102,
Yes.
101, 98. So see, this right here, that's the beginning of fall for me.
Yeah.
Wow.
The low below 70, it's fall time. Other than that, so let's see, what's that tomorrow? October 6th, first day of fall in Arizona, in Phoenix.
So, Scotty, your low is our high right now, but next week we're going to be in the 80s
For your high,
for our high.
what's your low like at night?
50s.
Well,
Yeah, our
we're
low.
planning
Been
to,
as low as the high 30s.
welcome
Our low
in
is 43 right now.
another hurricane, a direct hit from another hurricane.
Oh yeah, that Yucatan one's coming across to hit you
Coming.
again, right?
Supposed to come right over us once again. That's supposed to come in along about Friday, Saturday time frame.
I think
There's 49 other states you could live in.
I don't know if anyone else has had this, but we've already had our killer frost.
Oh,
A
no,
frost?
we haven't had that.
I think 39's as low as we've gotten here in Missouri, but
39 is about as low as we ever get here. I don't know. I kind of like fall, but it's kind of the tree we have in the backyard. The only way it loses its leaves are the new leaves push the old ones off. I'm not kidding. It loses its leaves in January.
Well, that's right.
Yeah, we've already lost ours. It's all turned and fallen down because we have a drought going on and we had a very early frost, and they just said, "Well, we're done."
ours
Yeah,
are fairly pretty.
So my leaf raking is about Groundhog Day, which is really not right. That's about right.
So Dave McGaw, I guess you've got some fall colors this year with the weather.
Well, that's what I'm saying is that right around here, it's actually already passed. Normally, it would be first, second week of October. It's getting towards peak. but right here between the drought and the early frost, we've already passed peak.
Wow.
But there are other places that are still quite spectacular. It was a very nice show, just went quickly.
Yeah, we generally don't get much in the way of colors on the trees here because we don't really have any freezing weather until maybe the last week of December, first week of January, and then it warms up again. And so the leaves on the trees just turn brown.
Right.
Well, it's starting to turn here in the Upper Peninsula of Michigan. It's already turned, and down here in the around the metro area, Metro Detroit area, it's starting. Nathaniel, did I hear you say you're replacing your furnace?
Yes, possibly.
Check out for a system-wide HVAC system. What I did, I have a heat pump with an auxiliary high-efficiency gas furnace for those days when it gets really cold, you know, like down to the 20s and 30s.
Yeah.
Otherwise, my air conditioning and primary heating, it's the same unit. It's a heat pump.
Yeah,
Works
I've
really
heard of
good.
it.
Yeah, it's a little more expensive going in, possibly, but it could save you money in the long term, and it's far more efficient.
Mm.
Yeah, it's cheaper. It's probably electric heat might be cheaper than propane, depending upon, because propane is fairly expensive.
Yeah, the only time you burn natural gas or propane is when it's like below 35, 40 degrees Fahrenheit.
Mm-hmm.
Otherwise, it's all electric heating and AC from one unit. One unit, one push of the button.
We have those all over Arizona and Phoenix because it rarely gets below 35 degrees. So they have what they call emergency heat, which is electric heat strips. And it's funny because when I moved into a house that had a heat pump, I never had one before. It said EM heat. And I thought that meant energy miser heat. So I turn it on. Oh my God, my electric bill was like double that much. So
wow.
But it doesn't work well at all below 30 degrees. Just doesn't.
The heat pump doesn't, but you know,
that gas I never heard of it paired with the gas furnace. That's cool.
Yeah, it's well, up here in Detroit, of course, you need it. So it's a 90% efficient furnace, gas furnace, and it's totally user transparent. You just go heat, normal heat, and it goes, you know, heat pump, heat pump, heat pump, and there's a sensor outside. When it gets below a certain point, it just goes, okay, heat pump's done, turn off, turns on the gas, house is warm, no problems, works really good. Happy,
nice.
happy, joy, joy.
The modern heat pumps are pretty good at low temperatures. I think our emergency heat strips only come on when it's below 20 degrees here. The regular system is good all the way down to that point, and it rarely gets below 20 here. Maybe once a year or every 2 years it'll go below 20 overnight, but that's fair.
Yeah. My problem with heat pumps is that they only produce about 75 degree Fahrenheit air. So if you're like me and you like to sleep when it's cool and then wake up and heat the house up, with a heat pump it takes 3 hours to heat the house up. With a gas furnace, I can do it in 15 minutes.
Yeah, I kind of like the 15-minute approach.
Yeah.
I can remember it being, I don't remember in Birmingham, but I lived there a long time, but I can definitely remember it getting to be 7 below in Atlanta on one occasion. And believe me, nothing in Atlanta is built for that. There was a plumber's, you know, we're going nuts.
Well, you also have to know Dave lived in Minneapolis too, so
yeah, grew up in Minnesota, so yeah, I know that. So I remember the half-inch of ice on the inside of the windows every
on the inside.
On the inside, yeah, your breath, yeah.
I had a house like that in Ohio. Yeah.
Wow. I imagine it's gonna be pretty cold here because we're more in the mountains and in the woods and stuff.
Yeah,
so.
it'd be chilly.
Yeah. Probably colder for.
Let's let Nathaniel go to bed.
Yeah, let's go.
Go QRT. 73 all.
73 all.
73. Good night, everybody.
Hey, Nathaniel?
Yeah,
leave this on for Dan and I for a few minutes?
sure. I'm gonna stop the recording. Yes.